Like you said, my name is Billy Hoffman. Just a little bit about me. I actually run the HP Security Labs. So Spy Dynamics is an Atlanta startup. Been around for about 5 years, had 120 people, and we got bought by HP about 3 months back. And so I kind of started there. As the intro said, I used to do a lot of things that probably aren't as legal as they should be, and it's amazing how lawsuits will change your perspective of the world. Especially when you find out that people will pay you to do what you were going to do anyway. So I've been in the security space for about 6 years, ever since I figured out people would pay me to be curious. I have a CS degree from Georgia Tech. I mainly focus at Spy Dynamics, well, now HP. We build products, you point them at websites, and they find vulnerabilities. Who here has heard of cross-site scripting? Who here has heard of SQL injection? Who here has heard of blind SQL injection? Excellent. We'll get into some of that fun stuff. But I mainly focus on how do you build massively paralleled, multi-threaded web crawlers. Anybody can write a web crawler in about 8 lines of Perl, right? You've got a queue, you scrape links, you put them in the queue, and you keep going till the queue is empty. When you start having to deal with JavaScript, Ajax, Flash, you've got a CAPTCHA, right? CAPTCHA is deliberately designed so that programs can't understand it, yet we have to make programs that understand it. So there's always a lot of fun stuff, and normally it has nothing to do with security. I frequently present at hacker security conferences like Black Hat, DEF CON, CanSec. So today I'm really going to be talking about Ajax and Ajax security and kind of how Google Web Toolkit, what are some of the features of Google Web Toolkit, and how it relates to these things. Now, everything I'm going to do today, I'm not going to do SQL injection. I'm not going to do cross-site scripting. I'm not going to do any of your normal attacks. We're going to do everything today with just a web browser, and that's it. And we will find out that we will do all sorts of fun things. And the key here that I'm really trying to focus on, thanks for joining us, Scott. The key that I'm really trying to focus on here is that attackers are lazy, right? They're going to go for the low-hanging fruit. And what we're finding is that SQL injection, cross-site scripting, which is rampant, just horribly rampant in the internet, it's actually even easier to break into websites than having to use that. And so really we're going to focus on how I can manipulate client-side logic. The big thing about Ajax, right, is that a substantial portion of your application is now running on the client. But the number one rule of web security is you can't trust the client. And we're going to see how kind of this interplay of having code that's running on the client, that's communicating back and cooperating with the server, what does that mean? How can we manipulate that logic to do evil things? We're going to talk about how to defeat various types of logic protection techniques, obfuscation, on-demand loading, things like that. We're going to talk about how to hijack the actual API of the application, how to clobber functions, automatically man in the middle the programming logic. We're going to talk about Json hijacking, which is a great way of basically stealing data from web services. And then finally, if I get a chance, I'm going to talk about hacking Google Gears a little bit. Because Google Gears I just love, right? We're talking about you can't trust the client. Google Gears is we're going to push so much of the application to the client that it does something meaningful when it can't even talk to the web server. But remember, you can't trust the client. There's a fundamental paradox there, and it's very interesting how that plays out. So I talk a lot about Ajax security. Actually, let me do a side tangent. I'm from the South, and I've been drinking lots of Red Bull, and I tend to talk kind of quick. So if I'm going too fast, by all means, raise your hand, ask me to slow down. And if you have a question, I'd much rather you interrupt me than go all the way to the end and find out that there was something that I didn't explain very well. So I talk a lot about Ajax security at conferences, and I've been talking about things like the increased attack surface. You have all these form inputs plus web services. The fact I can directly talk to the API, that it's way easier to reverse your app because you're pushing parts of your application in client-side JavaScript or Flex or what have you. We're talked about how you can amplify web attacks, talk about offline attacks. And a lot of the times when I start talking about these things, saying, oh, there's a web service here that you can just send PHP code to and it executes it. People say things like, surely no one's that stupid, right? No one designs websites like that. So I'm going to talk instead about sexy Ajax security, which is I'm just going to build an application and show you all this stuff. So what I did is I went out and I built everything using expert advice. I went out and bought your very popular Ajax books, Ajax in Action, Ajax design patterns, things like that. I went to very popular articles. I read tons of stuff on Ajaxian. I went to tutorials. I went to Experts Exchange. I read stuff on Google forums. And I basically took snippets of code and advice and things like that, and I built essentially an Ajax version of Expedia and it was riddled with security defects. And you have to understand, as I'm going to show you this app, I didn't bake any of these in. Never once did I say, you know what, I'm not going to use the parameterized SQL statement here. I'm going to use an ad hoc SQL statement because I want to put a SQL injection vuln here. I just used everything. It's frightening how poor our resources are. And this is a conference with a lot of Google people, so I always beat up on Microsoft, but Microsoft is the worst of this, right? All of MSDN, every single example they give you on MSDN that uses SQL statements, every single one of them is SQL injectable, except for the one page that discusses how to use parameterized queries. So when you go and you try to find out, how do I do something, right? Ajax is new. There really aren't any experts in the field. So when you go and you try to find expert advice, what I found is that a lot of this advice is blatantly wrong. So let's go ahead and just show you this application. Let me flip over here. As it loads up. So basically this application, I built it using all sorts of data that I ended up getting actually from online, little course snippets and lots of web services and such. Wow, that's a long time to listen to localhost. Wow. There we go. Okay, cool. So basically it's Hacker Vacation. Can you all see that? I can bump that up a little bit more. Where you name your own price, and we'll find out, sure enough, that's very, very true. Now, what I'm going to do is, it's just a very simple site. I'm going to go ahead and log on. Just spy, and we find out that you can do all sorts of stuff that you normally can with a travel application. If you think about things such as, searching for flights. So let's go ahead and find me flights from Atlanta to Vegas. Sure. There we go. This is taking a little longer than normal. That's odd. So we go ahead, we sent a request, the page didn't update, we got some things down here at the bottom saying, hey, great, here are some flights you can bid on. So let's go ahead, we see this Delta flight that's leaving at 8:30 in the morning. There are 9 seats remaining, so let's go ahead and place a bid on that. So we come over here, I'm going to make an offer of, say, $49. I do not have a promotional coupon. Go ahead and make a bid, and we see down here, making a bid, or holding the seat, making the bid for $49, offer refused, releasing seat, done. Okay, interesting. Let's go ahead, make an offer for $99. Oh, yes, it's right here. Gotcha. Hold on, let me do this. How's that? All right, sorry about that. So we see right here, go ahead, holding the seat, it was evaluating my $49 offer, said, no, I'm not going to accept that, released the seat, and then said done. So I went ahead and made another offer for $99, went ahead, held the seat, offer accepted, went ahead, booked it, the seat was booked, debited the account, and done. All sorts of really cool things. In fact, that's not going to go. If I come over here and check my itineraries, we see that I have 1 flight booked, everything's great. So let's go ahead, come back here, and let's actually see what's going on under the covers here, right? Let's go back to the Search API and find out what's going on. Now, I'm sure you all know, use, and love Firebug, right? Everyone loves, if I ever meet that man, I will accost him in ways my wife probably would not like. But seriously, it makes my job so easily, so easy. All right, so I don't know a way to increase the font of Firebug. I guess that's one thing I'm going to have to tell him about after I thank him profusely. So I'm going to try, I can probably, oh yeah, I can do this. So I'm going to go ahead and just copy this location. First thing I'm just going to do is I'm going to use inspect, and I'm going to say, you know what, show me what happens when I actually click that search button. Find flights. Ooh. Inspect. Find flights. And it actually says that it's going to, you can't see this, but it says on click search for flights. So I'm going to come over here. We're just going to view the source of it. Oh, that's kind of funny, right? I actually hit this every now and then. I right-clicked on the page to do view source, and it said this feature is disabled. I kid you not, if you go and do a Google search right now for JavaScript right-click suppress, it's 2007, and there are still people who think that you can somehow protect the JavaScript code or the HTML code from being viewed. Apparently, these people have never heard of, Telnet. I'm just going to Telnet to port 80 and fetch your content. You absolutely cannot trust that anything you put to the client will work. And this is just a bad example. So I'll go ahead and just Control U, see the source. Seriously, I kid you not. Go look. You'll see some guy post like 2 months ago. Seriously, I figured out how to do it this time. And it's like, you're never going to get there. All right, so we see search for flight. It basically goes ahead, grabs the from city, grabs the to city, grabs the departure rate, and it calls this thing called Ajax calls flight service. We see it passes the origin city, the departure date, and the callback. And then when it actually gets called back, interesting, we see a fun little variable declaration right here. It says max results is 3. Remember, we only saw 3 flights come back. On the callback, we go ahead, we parse the HTML, pull some information out, clear out the old results, and then right here, results to display is equal to the length of the table I got back. If it's greater than max results, just give me the max results. Well, that's interesting because I'm doing a flight search. Potentially, I'm getting more data back from the server, but it's actually limiting what I can see. So let's go ahead, poke around on this. I want to go from Atlanta to Las Vegas, and you'll just have to trust me on this. I'm coming down here, and I'm putting a breakpoint right here in the code. I'm going to come over here, find me some flights. And it actually hit the breakpoint right here. We can see the length of the table is 7. And sure enough, I love this aspect of Firefox. I can see the net traffic. And we see right here that there was a request to find flights.as or ASHX. And we can go ahead and see from the response of that, request format invalid. Interesting. I'm going to go ahead, run this. So we can see that for some reason or another, close that, we get back these 3 flights. But if we actually look at the data that went across this, hopefully that's odd. I wonder why it's saying that. Well, we saw from the debugging that there were 7 results returned. So I'm going to flip back over here. I still have the breakpoint, so I'm going to find the flights again, and we hit it. And sure enough, if we look at table results, y'all can see over here with text, kind of hard to see, there's a giant data set table that got returned. In fact, let me just do, I don't even know if that'll work in the context, but let's try it. Alert text, so hopefully y'all can see it. All right, so there's our actual table, and we see that there are numerous things returned here. We see 1, 2, 3, 4, 5, 6, 7. So we're actually getting 7 results back from the server, but on the client, they're actually filtering and saying, no, only show them 3. Well, I don't know about you, but I don't like to take flights at 8 o'clock in the morning. I want to see what other results are there. So I'm going to go ahead, step the code, step the code, step the code. We see that results display has been changed to 3. No, I'm going to change it back. 7. Run the code. And sure enough, we see a lot more flights. Now, 1042, that's more along my likings. So here we see that there was a soft limit imposed in the client-side code. But remember, you can't trust the client. You can't expect that code won't be modified. So I just got access to more flights than the application is supposed to give me access to. So let's go ahead and move along and go ahead and I like this American Airlines flight. Let's go ahead and make this bid. And we know that $99 works. Now, let's go ahead, just like I did before. Let's find out what actually happens when I make these calls. So I'm going to go ahead. I'm going to inspect the element on make bid. And you can't see it, but right here, it calls a function called hold seat, which is interesting. I'm going to actually come to the code. Let me come over here, copy. This is probably the easiest way to show the code. Control U, tick, tick, tick. All right, so it went ahead and calls hold seat, in which case it prints holding the seat, goes ahead, grabs the flight number, and makes an Ajax call to hold the seat. And then on the callback, we see down here that if the results weren't good, go ahead, display an error. Otherwise, move to make offer. Make offer goes ahead and grabs my bid amount, grabs the flight number, prints out a nice little fun error message, and goes ahead and calls the web service make the offer. Now, on the callback, if it's OK, then offer is accepted. Otherwise, the offer is refused, and we go to release seat. Now, let's just go down and see what that is right here. Wow, that's not good feedback. All right, so release seat, we see they're printing release seat, and they're calling an Ajax function called release seat. Now, this makes sense, right? Ajax, the A in Ajax is asynchronous. So what we've got here is that multiple processes going on. So, if I'm sitting at, my hotel room, which is having really pathetic internet access right now, if I start making a bid on a seat, and somebody else comes along and who works at Google, who basically own the internet, and I bet they've got a really fast connection, comes in and snipes that seat out from under me, that would suck. So the way this thing works is that it calls hold the seat, goes ahead, does it, and then either releases the seat or commits a transaction. Think of it just like a database transaction. You lock it, carry out everything you need to do, and then either commit it or roll it back. We're going to come back to that in a minute, but let's go ahead. Whenever you're allocating in one web service and freeing in another resource, that's not very good. So if it accepts my offer, we go ahead to book seat, in which case it grabs the flight number, my username, and goes ahead and calls a web service book seat. OK, cool. And then it goes ahead on the callback, and then that if it was able to book the seat, it calls debit the account, otherwise it releases it. Debit, we grab the coupon value. We go ahead and call debit account. And then on the callback, we actually update the progress to done. So this is very interesting. We see that it's a multi-step process, right? Hold the seat, make the offer, book the flight, debit the account, confirm the transaction. Well, here's the thing, though, right, is that this is what I'm talking about. There's an interplay between the client and the server, and there's some data being stored on the client in the forms of JavaScript variables. Who here has ever heard of a client-side pricing attack? Client-side pricing attacks are used to see it back in the day a lot when somebody would put down a e-commerce page, and in hidden HTML fields, it would say price equals $9.95, which, of course, you could change the price before submitting it back. And indeed, I mean, this attack is so old. In 1997, a guy did this against a company called CD Universe, which eventually got bought by like CD Now and then Amazon. But he was buying CDs and realized I could save this page, change it to a cent, and resubmit it back. And he started getting CDs for 1 cent. Well, of course, they figured out what he was doing after about 3 months and got back to him, right? And I kid you not, oh, there we go. I kid you not, this was his defense. His defense was, you made me an offer, I made you a counteroffer, and you accepted it. I could only imagine him trying to plead this before a judge, and the judge going, you know what, that's clever as hell, but no. So, but here's the thing, right? That's 10 years old. Incidentally, if y'all are ever, I travel quite a bit. If you're ever staying at a hotel that, I can't really say the name of the hotel, but they have kind of a daughter who, I don't really understand it, but apparently she did amateur porn and that somehow made her famous to get TV shows and stuff and singing careers. Well, that hotel, all their internet access, when you say, I'd like to purchase internet access, actually takes you through a third-party clearinghouse, which does the billing. So you say, I want to buy this. And it says, OK. It gives you an HTTP 302 redirect to a centralized site. It's like IP3 networks dot whatever. In the query string, they pass price. So I kid you not, they pass price. So I'm using an HTTP proxy a couple weeks ago. I go ahead, stop the transaction, change the price from being $9.95 to a cent, let it go through. Next day, I go down and I ask for my bill. And they're like, Mr. Hoffman, you're not checking out yet. I'm like, I know. I want to see the bill. And sure enough, I had internet access for 1 cent. Well, being the nice guy I was, that next day, as much as it pained me, I trap the transaction, it comes back, it's like, do you want to pay $9.95? And I'm like, no, I want to pay $19.94 or $18, whatever. So I actually ended up having to, charge myself over so they got their correct amount of money. But the thing is that these types of attacks are nothing new. We've known about them for years. But JavaScript and any type of complex client-side app is very interesting because what's happening here is I can change the value while it's used. Let's go ahead and just refresh this page. And I'm going to go ahead, and we're going to put some breakpoints here. I'm going to put a breakpoint. Y'all can't see it, but right here in debit account. We're going to go ahead, and I'm going to offer $99 to this. And we see it's holding the seat, making the offer, booking it, and it just hit my breakpoint. I'm going to come down here and change, y'all can see over here, amount, not $99, $1. Continue. Close. All right, so here we see offer accepted, booking your seat, site booked, debiting account by $1, done. So this is very interesting, right? If you think about how things used to work in a non-Web 2.0 application, oh, that's annoying. Before, what you had is that all of this domino effect, right? Normally, I would take all of this form data and I'd do a post. And then that back-end web server would probably contact some database tiers, some application tiers. And it was probably calling web services like, hold the seat, make the offer, book the seat, all of that stuff. The thing is that once I sent that data to the web server, those variable values, I couldn't tamper with them anymore. So if the very first step they did was validate those inputs and make sure they were safe, there was nothing I could do. But in this case, there's an interplay back and forth between the client and the server, and I can essentially tamper with variable values while they're being used. This is something you can't do in a Web 1.0 application because the client doesn't play a meaningful part of the application. Now, this is very interesting, right? So it's web services. Why even bother calling hold seat, make offer, or debit account when I can just directly talk to book seat? Why not, right? So let's go ahead and see. We know that in this code, which I showed over here, it's actually making a call to flights. Oh, that's the search page. Man, that's so annoying. All right, control. All right. So we see that it's actually making a call to a web service right here, book seat. All right, the username, the flight number, and the book seat callback. So here's what I'm going to do. I'm going to come back over to here, and let's go ahead just for fun and pick a different flight so I can go ahead and book flights. In fact, let me just do this, manage accounts. That went ahead and just cleared out my itinerary so I don't have any itineraries booked. So y'all can see there's nothing up my sleeve here. Atlanta to Vegas, find flights. Still got that tick mark there, tick, tick, tick. Results to display, 7. We're going to come over here. I like this one. Let's do this Delta. I got to support local business. All right, so let's go ahead, and I'm just going to come down to Firebug here, console, and I'm going to go ahead and call Ajax calls book seat. Now, I know what my username is, right? My username is spy. The flight number is DL1869. And the callback function, let's just do window.alert. So we can just see raw what's coming back from the web server. Posting. OK. Interesting. Itineraries. Book seats. Success. So what I'm doing here is I'm directly manipulating the API of the application. Again, remember, in a Web 1.0 world, all of this was basically hidden, masked on the web server. In fact, the way you could think of this was really you had something like this. In a Web 1.0 application, it hit the database, or it hit the web server and then contacted all these database tiers. What we see a lot of times with Web 2.0 apps is people take all these other database tiers, open web services to them, and push them to the perimeter. So there probably was a web service called, hold seat, all of that stuff. But instead of those only being able to be talked to by the web server, they're now actually pushed to the perimeter. They're exposed, and I can talk to them, and we can see what happens. Now, remember that fun little hold seat, release seat? Allocate a resource in one web service, free it in another. Remember, you basically told JavaScript the way this control flow is going to work is call these web services, and if there's an error, go ahead and call release seat. But remember, you can't trust the client to run the code in the fashion that you told it to. So what happens if we just call hold seat a lot and never call release seat? Let's find out. So I booked a seat on this plane, and quite frankly, I'm kind of greedy, right? I don't like sitting with other people who have whiny children and annoy me. So I'm going to go ahead and just, this is the call I'm making. I'm going to come down here to the console. All right, the flight number, DL 1869, and the callback, I'll just do window.alert. All right. Okay. Okay. And you can see I'm making the posts down there.
Aren't you releasing seats?
I'm not releasing. Oh, wow, you're right. I am releasing seats. Excuse me. Thanks. That probably explains why it's saying OK all the time. All right, my bad. Let's go ahead and, well, actually, I'll just come down here. Let's change that to, sorry, hold seat. OK. 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 Can't do this forever. I'm not sure how many seats there actually were on it, especially if I ran it a bunch where I was releasing the seats. Oh, wait a minute. Error B081, info available seats equals -1. So what I've done, right, is essentially called the hold seat web service without ever calling a free. Now, think about this from the server's point of view, right? Because if you're trying to defend against it, you have to think what the server sees. The server sees 12 people just simultaneously said, I want to go ahead and book a seat. Now, the other odd thing is that they must be on a really, really slow connection because they haven't called the subsequent web services yet. So the web server is just going to sit there waiting. You know, it's not actually sitting there with an open, you know, say, well, actually it does have an open HTTP connection, but it's sitting there from a logical point of view saying, I'm waiting for the next step. And that never happens. And if we come back over here and search, and if I go ahead and refresh this, we see seats remaining is 0. So even if they have, say, a database process, you hope to God every 45 seconds sweeps through and kills any open transactions that just, you know, like I'm on an EVDO card and I drive into a tunnel, right? You know, you'd hope they would have something that comes through and clears out these, you know, orphan children, basically. But think about that. I sent, you know, what, 12? I basically send one HTTP request for every seat you have. I can send one HTTP request for every seat all day long. This is what we call a control logic denial of service attack, right? How do you knock Google off the internet? How do you do a denial of service of Google? You can't. They've got all the bandwidth in the world. You're not going to win, right? But this is kind of a more interesting kind of sexy attack, right? I'm not trying to do a SYN flood or a Smurf attack and just basically overflow your resources. Instead, what I'm doing is I'm taking the application that runs on top of those resources, and I'm using it in such a way that your application is going to freeze, crash, deadlock, all sorts of things like that. You know, this is very interesting, actually, you know, because you can't knock somebody who has tons of resources off the internet. And actually, what client-side code is essentially a blueprint of how your application is supposed to run. So as an attacker, what do? I do the inverse. I call hold seat without calling release seat. I send negative numbers to your web services. Everybody here ever have to read an RFC? Painful, right? So RFCs are incredibly anal. They actually have part of the RFC which defines, you know, what you should do, like what the word should means and what the word always means or never means. In fact, those are normally capitalized. So I wrote a fun little Perl script called RFC break, which scans through an RFC, takes all the sentences that has stuff like, you know, the SSID on WEP must be great or must not be more than 16 characters or something like that, and must not or is always or cannot be, never, things like that, and it just reverses them. And it basically gives me a list of things to try to break implementations, right? It's like, go ahead and set, you know, the IP frag flag inside of a IP fragment to 1 when you actually don't have a frag ID. Go ahead and turn on SYN, ACK, and reset all at the same time and send that to a TCP/IP stack. See what it does. So you're giving the blueprint, you're giving the attacker a blueprint of how to use your app. But you're also giving him steps to say, this is how my app is supposed to work. Here are essentially the assumptions I make about the application. And unless you as a developer actually checked all those edge cases, that's giving an attacker a clear path on how to attack you. Does anybody have any questions so far? Are we doing good? Yes?
Do you know if Expedia.com is using Ajax?
Expedia is not using Ajax. But quite possibly even more frightening, E-Trade is. Yes? I'm sorry? Oh, all sorts of people copy and paste code in ways they shouldn't. Yes, sir. I'm sorry?
Yeah, I've run into this with malform UTF-8. It's now in the standards that you must not accept malform UTF-8.
Which is nice, right? You would hope people would actually do that. But then you got UTF-7, you got UTF-16, you've got buffer overflows inside of Unicode, you have all sorts of fun stuff. Input validation is very, very tricky in Web 2.0 applications. Now, what we've got here was essentially these multiple steps, which you then broke out and I executed on the server. What you really needed to do was send a single web service that said, hey, here's my username, here's the amount, here's the flight, book me a flight, and have all of that stuff happen on the background. But this is Ajax, right? You want it to be sexy. You want it to still be dynamic and find out, what's going on, be very responsive. So then you have a secondary call that's essentially a polling call that says, whoop, I'm going the wrong way, which essentially says, OK, I'm going to perform a long op and then get the status. Because that protects the application from having those data variables manipulated while it's actually processing them. I mean, essentially, when you've got a Web 2.0 app, it's like I've got a debugger attached to your backend server, depending on what you're doing in client-side code. So we see things that these web services, very, very bad. So let's see what other types of web services there are actually in this file, right? Because I noticed that there always seems to be this common JS file is included like on everything. It's included, I go to the itineraries page, it's there. I go to the search page, it's there. The itineraries page isn't even taking user input, yet it has a included JavaScript file which contains all sorts of Ajax file, or all sorts of Ajax functions that it's not even using. So let's go ahead and take a look at what this code looks like. So we see things like parse XML. I see what appears to be encrypted coupon values. In fact, a function called crypt. That would be fun. Go do a Google search for the Macworld hack. Macworld basically took all the coupon codes and MD5'd them and pushed them down in a JavaScript array. The only problem was they also had JavaScript code which saw how they normalized input before MD5'ing it. They took the input, stripped it, so it was nothing but alpha, not even alpha, I think it was alphanumeric. Uppercased it, and then MD5'd it. You've just radically reduced the key space that MD5 has there. Everybody here ever heard of John the Ripper? Phenomenal password cracking program. I can use John the Ripper, modified slightly. I can crack MD5 passwords like that, or hashes, seconds. And sure enough, he cracked every single one of them and got a platinum badge to Macworld, which is normally like $1,600 for free. Do not underestimate the stupidity of people. So we see right here, these are just some nice, fun functions. We see things like our find flights, our make offer. We see our using JSON. Now that's interesting right there. Employee discount equals 0. We'll have to come back and investigate that later. I want to make sure I have that. Book seats, debit account, hold seat. So really what we found is these things are the keys to the kingdom, right? This is essentially the logic of your application. And manipulating this is awesome. So we want to find what else is in here. Right? Because a lot of times, people will sometimes, because they'll have kind of a single file, they'll do this with style sheets, with JavaScript files. They'll kind of throw everything in 1 or 2 or 3 files, and then every single page on the website will include them. Because they're using, say, Smarty or some type of templating system, master pages in ASP.NET, what have you. Well, the problem is that there could be functions here that actually refer to parts of the website that aren't public. It's another part of the website that I can't see, but both public and non-public parts of the website share these common JS files. And if we deep down here, we see update seats, miles check club, update park, ajax calls.admin.add user. That sounds interesting. I don't know what that does, but it apparently makes a post to ajax calls add user and passes some JavaScript. So let's go ahead. I'm going to go ahead and fire up a fun little tool. So I lied when I said I would only use a web browser. I'm going to use something that's called an HTTP editor. All this essentially is allows me to craft HTTP requests. I mean, you can use Telnet to port 80. You can use tamper headers. Anything that an HTTP proxy that lets you basically trap and modify a request before it goes out. Peros proxy is an open source web security tool that's very good that'll let you do this. So I'm going to basically use this. And I'm going to contact, let's see here, localhost, port 80, and what is it? Hacker, vacations. /Ajax calls seat.ashx. So I'm just going to go ahead and send a request for that and just see what happens. I'm getting a not found. Let me go ahead and make sure. It should be ASHX. Yeah, let me go ahead and make sure I got this URL right, though. Because I probably fat-fingered something. We'll come back. Woo, not what I wanted. All right. So let's come back over here. Put this here. We know that it is in Ajax calls /add user.ashx. So I'm just going to do a get and make sure I'm getting. OK, so I'm getting a 200 OK, but it's saying missing error name, missing post. Interesting. Let's go ahead. We know that we're doing a post to this, right? Because it's called do post. So I'm going to change this to do a post. I'm sorry I can't increase the font on this, but I'm essentially doing a post to the web service. And I know it accepts JSON, so I'm just going to send an empty JSON array, because everything we've seen so far has been JSON. And let me go ahead and just add a content length to that. Send it. And our reply is, same that we saw when we just did a get. Error, missing username, missing name, missing password, missing debug flag. OK, so I don't really know how to use this web service, right? It's probably being accessed by a part of the site that I can't see. So I need to kind of finesse this thing a little bit and see what happens. So I'm going to go ahead and just do foo. That's a string. Change my content length, send it. We get a 200 OK. Come back here, missing name, missing password, missing debug flag. So I get a different error message. It's actually taking the JSON I'm giving it and doing something with it. I don't know what, but it's doing something. So let's go ahead. How many things were there? There was username, name, password, so 4 things, right? So I'm going to go ahead and do Google Web Toolkit, Google Web Toolkit, Google Web Toolkit, and debug flag as true. Apply. Send. 200 OK. Invalid value for debug flag. OK. Let's go ahead and try that as maybe a string. I don't know. Let's try true as a string. Huh, that's kind of annoying. This thing is clearing those out for me. Let me manually change these. 2006, send. Nope. All right, so let's go ahead and try, Just try white? Oh, just like an empty space? All right. Send. 500 server error message, input string was not the correct format. OK, so still types of problems. I'm going to try 1. Because in languages, or 1, 0, you got flags instead of true, false. So let's go ahead. Thank you. Let me close that array. Send. 200 OK. Success equals true. So I have no idea what I just did, right? But apparently it succeeded. And it probably involves adding a user of some kind that now has a username, normal name, and password of Google Web Toolkit, and hopefully is a debug user. So let's come back to here. My trips. Let me go ahead. I'm going to log out as spy. And I'm going to go ahead, log in. Google Web Toolkit, Google Web Toolkit. Log in. Well, that looks a lot different now, doesn't it? QA, hello, Google Web Toolkit. I've got this lovely little bar here called debug, right? Current users, toggle ads, set data session, load transaction, dump log, return to admin. I've got this lovely thing here. We see what appears to be a load server, a big IP, so it's probably got a big IP load balancer. I see a GWT associated with my session. What appears to be Unix uptime, which is kind of odd because this is an IIS server. Well, but it's possible, right? They've got some type of back-end load balancer, right? I mean, even Hotmail was run on Unix because, well, draw your own conclusions. So now, interestingly enough, it seems to be directly replaying my user agent. So this is probably cross-site scriptable as well. But remember, I haven't done any magical hacking. I haven't done SQL injection, haven't done cross-site scripting. I'm just screwing with stuff. Now, who knows what the most interesting thing on this page is? Raise your hand. What do you think is most interesting? Yes? Return to admin, right? Why is that interesting? Because I didn't come from an admin page, but I most certainly want to return to the admin page. return to admin. And I get a lovely null object reference, right? That's always fun. And a login page. Now, if we look at the URL here, we're at siteconfig/index.html. So obviously, certain types of web security products like Web Inspect, which we sell, will do what we call resource enumeration, which really is just a fancy way of saying guessing for stuff. Chances are we probably would have never guessed siteconfig. And I can go ahead and do root. Well, let's try admin. admin. No, tick or 1 = 1. I can bang on this all day, right? But the point is, I don't have to. I'm feeling lucky. I'm already the admin, right? Because what happened here is that you probably had the intended use was, normal users are going to visit the home page, which talks to certain web services in library.js, and admin users are going to visit the admin portal, which then talks to certain backend structures. But what I'm doing is instead of talking to the admin portal, I'm directly calling the web services that the admin portal uses. So you have authentication on the admin portal, doesn't matter. I'm talking to the backend web services, which you didn't check for authentication. So I essentially am admin without all the red tape of actually becoming an admin and talking to IT and getting passwords set up. Because chances are if I call your IT staff from an outside line saying, hi, this is please set me up with an IT password, they're probably going to get suspicious. And if they don't, you should fire them immediately. So the point is that I was able to get around all of these things. Now, why did this happen? Well, this is actually a real-world example, and I'm running kind of low on time, but what happened is that this was probably part of a multi-step process where you used to check for authentication before actually carrying out certain types of actions. But when you started to kind of Web 2.0 size this, to give it more responsive, you started exposing things on web services, but your trust chains and validation chains no longer apply because I can call things out of order. I'm just directly calling to them. My co-author and I like to call this premature ejaculation because you did not think through what you were doing before you went ahead and did it. I love using this clip art. So essentially, it's actually an album cover, and I'll give a copy of the book to anybody who knows it. But anyway, it's amazing what people expose. Now, man, I still have so much to talk about. So let's go ahead and scoot down a little bit. Notice that everything I did here was using Firebug, right? I'm changing and debugging. I'm doing all sorts of stuff with your code. Well, what happens if your code is a big, nasty pile of obfuscation, and I can't see what it's doing? Doesn't matter. So this is a JavaScript Reverser. And I'm not going to have time to give a demo, but essentially I wrote a JavaScript tokenizer and parser, completely independent of SpiderMonkey or Rhino. And went ahead and I take your code and basically essentially create tokens. We see over here, left curly, a variable token, a period, a variable, a left paren, a string literal called countSelect. We see all the variables and function names over here. And we see the actual nicely printed code. This is actually Google Suggest. So you might give me something that's nasty and obfuscated, but I'm going to reverse engineer it. And what we actually have now is, because we have full-blown static analysis of the client-side code, we'll do things like, what happens to that input when it's brought in? Oh, that input is used and you perform string ops? Well, I'm going to rename it from S to string capital S. So it'll actually do certain types of automatic type inference for you. Let me tell you, that's extremely difficult. I don't know of really any good IDEs that do IntelliSense for JavaScript. Microsoft says they do it, but I played around with 2008, and frankly, it sucks. So this is a hard problem, but you have to understand that you can make it so a computer or a human can't read it, but a computer always has to be able to read it. So I'm going to be able to understand it and reverse it. Now, the other fun thing people like to do is use on-demand Ajax, where basically what they're doing is they're saying, you can't debug the code if you don't have all of it, right? Firebug can't see dynamic code, right? If I'm pulling down code through remote scripts, or I'm making XML HTTP requests to fetch new code, and then I'm using eval to load it into the environment, Firebug is essentially view source. And what we really need is view generated source. We need to see how the environment looks as it moves. We need a way to monitor the environment. Well, a couple things you need to understand. JavaScript variables, essentially everything's an object. And global functions and variables and every function you declare are properties of the global object. Well, in a web browser, the global object is window. So can we enumerate the window object and find all the properties? Well, you can. If I have a function and a function, and then I basically iterate through the Windows object, and I say, find me all the functions and display them, you get something like this. And you'll see right at the top, bogus function 1, bogus function 2. We see scroll to, dump, set timeout. You know, we see things that are actually system functions. Down here we see blur and focus, alert, and confirm. So we actually can see these functions. Let's go ahead and come back over here. So what we really want to do is be able to monitor these functions. I actually want hook demo. So we went ahead and wrote some code called hook, which enumerates the environment and is with set interval and traps code. And the cool thing is it also sidesteps obfuscation, we'll see here. So I'm going to go ahead. Essentially what happens is this page, if we look at the source, has, no, you can't see that. Ah, crap. Man, I only have 15 minutes. I still have to tell you how to rip Google Gears a new one. Don't get me wrong, I love Google Gears, but there's a fun thing called worker thread, and worker thread continues to run after you close a tab. Shh, don't tell anyone. Especially if you're using worker thread to start shoving massive amounts of junk into the SQLite database. I can fill up a 20 gig hard drive in I think a little over an hour. So you're browsing, you go to a thread, I spawn a worker process, it keeps running. You close a thread, navigate away, doesn't matter, it keeps running, filling your hard drive with crap. It's beautiful. All right, so anyway, yeah, again, all the fun stuff I wish I had time to talk about. So we see here there are just two functions, right? A crypt function, and then I'm kind of hacking it, but basically here's a big function, there's a big blob of code, we decrypt it and then evaluate it. Now, if we look at this code in Firebug script, the only thing we see is the actual code. Now, what I want to do is I'm going to go ahead and run. I actually have loaded hook in here. Now, you could edit the HTML and insert hook dynamically. But I just go ahead and I come down here and I type hook.watch. And I want you to watch every half second, see the environment. And the very first thing that pops up, it says, all right, here, the current environment looks like this. There are two functions for 18 lines of code. There's one called hook crypt, and there's all your code. And then there's one here called load more, and here's the function. OK, great. Now, when I click this button, it's going to call load more, which basically is going to take that string of code, decrypt it, and then load it into the environment. This could be done through on-demand scripting. It could be done through XML HTTP request. I just simplified it for an example. There's no hand waving here. So I'm going to click this, and immediately hook pops up, and it says, code has been updated. There used to be 2 functions with 18 lines of code. There are now 6 functions with 30 lines of code. Show it to me. Well, we still have all that stuff, but now we got something new. Frame.sum, frame.square, what is that? Mod, and then fun one here, frame encrypt key. Yes, this is a little contrived. But still, I went ahead and monitored and now see that there's more functions in the environment. Let's go back to right here to Firebug. We don't see those new functions. If I actually come down here and I type alert of frame.sum to show you that that is in fact located into the environment of 3 plus 4, I get an alert box of 7. So those functions, thank you, 10 minutes. So those functions exist in the framework. Firebug can't see them, but Hook can. Now the funny thing here is, let's come back, load everything, and I'm just going to run Hook to monitor the environment again. And again, Hook is in our Ajax security book, which I'll talk about here briefly. Ooh, Hook not defined. Oh, little k. Not a little k, it's a big K. So now here's the funny thing, right? Here is that code where we used to have all this obfuscated code, but now notice that the actual functions, it's nice, formatted, and printed. When you call value of on a function, the JavaScript interpreter automatically basically adds white space for you to make it more readable. So once again, I can see everything your function does, everything your client-side code does, even if you're trying to load it dynamically. So trying to rely on client-side code is not going to work. Man, there's so much more to talk about. That's annoying. All right, so real quick, things to take away. Client-side code is just a suggestion. It can't be protected, encrypted, obfuscated, anything. You need to store all secrets on the server and enforce control flow, right? That whole, you need to call hold seat and then call, evaluate, offer, book seat, debit account. You need to do all that on the server, right? No business logic, which again, why Google Gears frightens me, because how can you have an app that's meaningful without putting some form of logic on the client? JavaScript function clobbering. This is all sorts of fun. So JavaScript, and I'm going to run through this. JavaScript's highly typed. Basically, you can redefine it at runtime. So if I have two different functions that both declare debug, the second one that declared debug clobbers the first. So what we have are JavaScript namespaces, right? I'm going to define a fake object and then just add functions to it to essentially prevent collisions. Well, what happens if I want to deliberately clobber a function, right? Let's go ahead, look at some code here. Index, clobbering alert. So here I am using the standard alert. Here I am, if y'all can see it, and the earth trembled with the message, hey, what are you guys doing on this roof? And it was good. So here's the code. Here's what I'm actually doing there. I've got alert. I then make a reference to the old alert, define a new message, which does some stuff and calls the old alert, and then I what we call shimming it. I basically redefine alert, a window.alert. So now when I call alert, it's calling my function. Okay, that's kind of cool that you can clobber system functions. You wouldn't think that you could do that. But what else can you do with this, right? What about clobbering prototypes request or ajax.request? So I'm going to go ahead and basically ajax.request points at the code to run it. And then when you have a success, it calls the onSuccess code. What I'm going to do is shim two pieces in. I'm going to shim in my code so that my code gets called when you call ajax.request, which then calls prototypes code. And the onSuccess is going to call my capturing function, which is going to steal all the data that got returned back from that request before passing it on to the user-defined request. I have dynamically man-in-the-middled your programming logic. And Google Web Toolkit is vulnerable to this. Everybody is vulnerable to this because it's just the way JavaScript works, which is why gadgets and widgets are scary as hell. Because if you don't properly iframe jail them, one widget is going to be able to tamper and hijack the logic of another widget and trap everything. Let's go ahead, come back here. Shimming Prototype. So here's what we got, and I'll show you the code. Essentially, we make a reference to the Ajax request. We create a new one called fake. It's going to go ahead. We're going to create a callback function which traps before calling their old callback function. We're going to shim our function to be the success, and we're going to go ahead. I have to create some fake events, and then I actually have to clobber the old ajax.request. So now when this normal program tries to make an Ajax request for data, what's going to happen is it's going to call this transport function. It's going to call my code first, which is going to trap the outgoing request. It's going to call my code on the callback, which is going to steal the data before actually passing it back out. Let's see what that looks like. Send request. And you all can't see this, but it says captured traffic. There was a GET request to data.xml, and the response was 200 OK with the listing of the books. Now this is my code that's running, the evil code. And when I click OK, my callback function is going to be done, and it's going to pass control back to the regular callback function, which just displays success and what came back from the server. I wish I had more time to go into this, but essentially we are clobbering and attacking the actual programming logic. Is that pretty clear? Did y'all get that? Yes. Oh, 5 minutes. You're not actually asking me a question. OK. Does that make sense? I know I'm going through this pretty quick, but OK. JavaScript, being as dynamic as it is scary as hell. So, all right. So there are limitless possibilities, right? This is the joy that I love. There are certain system functions you can't clobber, right? Like I can't clobber document.cookie, because document.cookie is a little fun. You set things. It's not really a function. You're setting a variable, but it's acting like a function. It's very kind of odd. That's where fun things like Dojo storage come in, because I can't hook when you're setting data from a cookie or retrieving data from a cookie, but I can dynamically man in the middle your Dojo storage functions, which are transparently sitting on top of, say, Flash local storage, DOM storage, Google Gears SQLite database. Any of the stuff it's sitting on top of, I'm hooking it coming in, and I'm hooking the data coming out. Callback functions, encryption functions. You know, with Google Gears or with dojo.offline, you've got this lovely little encrypt function to decrypt. I can hook and trap your encryption key as it flies across memory space. So it's limitless what you can clobber, and there's nothing you can do about it. Sorry. The myth of the same origin policy. The same origin policy essentially prevents JavaScript from seeing third-party content, or at least that's the idea. That lies. It kind of prevents you from seeing this stuff. Go ahead, do a Google search right now for JavaScript port scanning. We wrote a code that basically using the events of an image object or an iframe, we can't actually see what gets returned by a third party, but we can know when it's loaded, whether there are errors, whether that the iframe successfully loads, and we actually can use this to port scan internal networks and fingerprint web servers, which are lots of fun. If you think about third-party plugins, right? JavaScript can't talk to, JavaScript from bank.com can't talk to evil.com, but JavaScript can talk to Flash, which has sockets, which can talk to them. So there are lots of holes with the same origin policy, and it just doesn't work. I also suggest you do a Google search for a piece of code called GWT. I actually wrote a web application vulnerability scanner written nothing but JavaScript. You visit a page, and it starts crawling your bank with your credentials and SQL injecting the bank using your credentials. Guess who they're going to come after? And extracts data out. I also wrote a tool called Dominatrix, which is spanking the DOM the way the DOM likes it. It's capital DOM. I really come up with the names before I come up with what they do. Yes?
But I could get that code and like use your ID.
Oh, sure. That's the thing, right? You can do this to anybody. That's the scary stuff. The same origin policy is totally busted.
How do you spell that?
GWT is Jikto. There's a webcast on spydynamics.com. There's some white papers about this stuff. I've got like 3 minutes. So there's this fun thing called Json hijacking. Everybody here heard of Json hijacking? All right, I'll go through it. JSON is a valid subscript of, hey, is somebody talking immediately after me? Is there like a 5-minute break? Sweet. All right, do y'all want me to run over like 5 minutes so I can stop talking so fast? Okay. I'm going to have to take a big drink of this.
You have to keep talking fast.
I can keep talking. Are y'all being able to follow? Yeah. I was in Japan for Black Hat Japan. Man, that was fun. I'm going through a translator. What's really odd is when you tell a joke and then 45 seconds later everybody laughs. And I'll tell you, actually, at the conference, there's something so satisfying about someone who spends their days writing really bad JavaScript to be sitting in this presentation and just see, kanji, 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 XSS, kanji, 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 cross-site request forging, kanji, 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 all sorts of stuff like that, Spy Dynamics. It's really cool. It's the universal language of exploitation. Essentially what we've got here is JSON is a subscript of JavaScript. And so eval could potentially see the response of, eval is evil. Essentially, could we read remote web services, services that return JSON? Well, think about this. If I take JSON and I say script source equals gmail.com / I don't even know what the URL is. Let's just say contacts, right? Google used to be vulnerable to this. They fixed it. I go ahead and I point the source of a script include to be gmail.com / includes. In this case, I happen to be pointing it at Hacker Vacation, and I'm hitting a web service that returns my most recent trips that a user had. So if we do that, if you point script source at something that returns JSON, you pass everything in the query string, your cookie gets attached because it's an outgoing request. What comes back is essentially a big block of say, either a Java object or a Java array literal. Essentially, it would look like this. Well, what happens? What does that code do when the JavaScript interpreter tries to execute that? What happens? Well, we have to think about what does the JavaScript interpreter do when it handles literals, because that's what JSON is. It's objects and array literals. So if I put this into a JavaScript interpreter, what happens? Well, the first thing it does is creates a temporary array object for that array literal. It then executes the sort function on that temporary object. Now, I'm not assigning it to anything, so those two things happen, and then nothing happens, and the garbage collector ends up coming along and sweeping it away eventually. But actually, something else happens. When you create the temporary object, it invokes the array constructor function and then executes sort. Well, what did we just determine? I can override any function, including constructor functions, in the entire JavaScript environment. So what we're going to do is we're going to clobber the array function with a malicious version of our own. We're then going to point script source at some JSON web service. The web service is going to go ahead and return a big block of JSON. The interpreter is going to execute that code, run my malicious constructor, which is going to steal all of that data. And remember, remote scripting, script source includes, aren't governed by the same origin policy. So essentially, if I write a constructor like this, I use a closure, and I set the variable foo equals to the current JavaScript object. I then create a function called bar, which iterates through itself, pulling out all of the values. And then it's going to go ahead, and I go ahead and say at the end of the constructor, in 100 milliseconds, call this function. So essentially, I'm creating this temporary object, but in 100 milliseconds, the temporary object is going to execute and then basically query itself for all its values. So what happens here is imagine going to evil.com. You get pushed down a piece of HTML. That HTML is going to go ahead and maliciously set up the environment by clobbering the array constructor with a malicious version, and then it's going to go script source and point to hackervacations.net. In the book, we used high-tech vacations. This is actually a picture from our book. And what's going to come back is a JSON array. Well, that JSON array is going to get executed. My malicious array constructor is going to execute, steal all that data, and then send it back to evil.com. Here we actually see this is evil.com, but evil.com was able to steal the contents of hightechvacations.com, or Hacker Vacations. We just renamed it. And see, sure enough, we see Ajax World. Those were my flights. The honeymoon. Those were the airlines or the cities I went to. False. So this information right here that evil.com, notice, is able to see. Gotta love a fave icon of Skull and Bones. Is all of that right there. So Json hijacking allows you to steal data from remote web services. Now, how do we fix this? Well, XML HTTP request can see a response from a web service before having to perform basically operations on it, like eval it. Script source can't. Script source says, give me this code, and then it passes it to the JavaScript interpreter. So what we do is we make the response of the JSON web service invalid JavaScript. That way, XHR, when it calls it, can remove that before serializing it back or deserializing it back to objects. And script source won't be able to. A big thing we see is that people will go ahead and stick an invalid block of JavaScript syntax at the front of what gets returned. This is a bad approach. The reason it's a bad approach is there's a lovely event called window.onError. And on certain browsers, I can actually hook the onError event and see the block of JavaScript you were trying to execute and say, there's a syntax error in following line of code. And depending on how many carriage return line feeds are in your response, I actually can still see the data that came back. Another really bad response, and Google Web Toolkit does the right thing. We'll get to this in a second. Prototype, the other guys, bad. They go ahead and they say, well, we'll just return JSON inside of a comment. So when the interpreter tries to execute this, it's all commented out, nothing happens. The malicious array constructor doesn't get called. Well, what happens if Eve and Nitty, or maybe Eve just creates two accounts and names her name Eve */ bogus and then that? Well, that actually ends up being looked as start a comment, end the comment. Ooh, that's loud and annoying. There's my array right there. And then Nitty goes ahead and starts the comment again, which goes to there. So in fact, this array does in fact get passed to the malicious array constructor, and thus I'm able to steal the data. The correct approach is to put in an infinite loop at the front. Now, Google Web Toolkit does, I believe, wow1. Is that right, Scott? You don't know? It's something like that. Gmail does this, and I guess Google Web Toolkit doesn't have to natively do it, but just the web services. They'll do wow1. The reason wow1 isn't good is that some JavaScript interpreters, when they see 1, what is 1? 1 is a numeric literal. Well, what happens when you encounter a numeric literal? You call the number constructor. I can redefine the number constructor so that the value is always 0. So if you say wow1, actually it's wow0, and it falls out and actually executes my code here. So by putting 4 and just semicolons, there's absolutely nothing somebody can do to clobber this to make it go.